Welcome back to our flipped classroom for chemistry and the final lesson on Unit 1. And so today we're talking about the classification of matter, or the ways that we organize it and categorize it. So we're going to start with the first broad categorization, and that is that we can break matter down into two types. One is pure substances and the other is mixtures. And so when we talk about a pure substance, it is something that is always the same, no matter what its source is. So if we were to look at water, water is always two hydrogen atoms and one oxygen atom, and they're chemically bonded together. And it doesn't matter what the source of that water is, that's always going to be the chemical formula of water. The other categorization is mixtures. And mixtures are combinations of different compounds or elements, and they might vary depending on where we get them. So if we were to go back to our example of water, although water itself is always two hydrogen atoms and an oxygen atom chemically bonded together, if we were to look at lake water versus river water versus ocean water, those are all mixtures. So although they contain water, they also contain other things. And depending on the source, those other things are going to be different. And so a mixture is going to vary with its source, but a pure substance is always the same thing. So we can break those down even further. So let's talk about mixtures first. So mixtures, as I said, have variable compositions depending on their source. Another important characteristic of mixtures is that they can be separated by physical means. And the components of a mixture retain their own chemical properties. So the water in our lake water or river water or ocean water is always going to be H2O, two hydrogens, one oxygen. It's going to have the characteristics of water. The other things within that, the salt in the ocean water, the dirt in the river water, those are also going to retain their own chemical properties. We have two kinds of mixtures, and those are homogeneous and heterogeneous. So a homogeneous mixture has a consistent composition throughout the whole mixture, whereas a heterogeneous mixture does not have a constant composition throughout the mixture. If you sample it in different areas of the mixture, you're going to have different ratios of the components of the mixture. So a great example of a homogeneous mixture would be spring water. Whether we take a sample at the top of the bottle or the bottom of the bottle, anywhere in the spring, it's going to be the same. Natural gas is another mixture that's going to have a very consistent composition. When we talk about a heterogeneous mixture, one that has an inconsistent composition, so fresh lemonade or orange juice is a great example. If you don't shake the bottle, you're going to have at the bottom lots of pulp and at the top very little. The sugar might be fairly consistently mixed throughout, but the other components are not. Dirt is another great example of a heterogeneous mixture. So we can think of lots of different examples. Most things that we encounter in our daily lives are mixtures. Another great example of a heterogeneous mixture would be cereal. So if you think about Raisin Bran, that you're going to have all the flakes at one part of the box and all the raisins, for whatever reason, always seem to fall to the bottom. A homogeneous mixture, consistent all the way through. Okay, let's talk about these pure substances. So pure substances have the same composition no matter the source, and it has one consistent chemical identity throughout the whole substance. So unlike a mixture where each component retained its own chemical identity, the whole pure substance has the same chemical identity. So we can talk about compounds. Compounds are made up of multiple elements, but always have the same composition, regardless of the source. Oops, my slide's a little out of order here. So things like pure water or propane. So notice that when we talked about mixtures, we talked about natural gas being a mixture. Propane, on the other hand, is a pure substance. It is a compound. Natural gas is made up of propane and several other alkanes like butane. Elements can't be broken down into other substances by ordinary chemical reactions. An element is the smallest unit that retains its chemical identity. And it can't be broken down by ordinary chemical reactions. We can break it down. We know that elements are made up of protons, neutrons, and electrons. But if we break it down, we change its identity, and we have to have a nuclear reaction in order to do that. Okay, so two main classifications, mixtures and pure substances. Now, one of the things that we say about a mixture is that because it is not chemically bonded, it can be separated by physical means. So these constituents of a mixture retain their own identity and they can be separated physically. Just as in the separation of a mixture lab, you guys use the characteristics of the constituents of the mixture, the components of the mixture, in order to separate it. They do retain their own identities and can be separated physically. So a couple of examples of ways that we can separate mixtures. If we have something like an ink or a dye, it can be separated by paper chromatography. So we're going to practice that in class today. And that has to do with the different dye's attraction to the paper versus to the carrier. Distillation is a very common form of separation. So in distillation, you're trying to separate out two different liquids, and you're relying on the fact that those two liquids have different boiling points. And so by heating up your mixture, the component of the mixture with the lower boiling point is going to boil off at a lower temperature. It runs through this condenser, which it has cold water running through it, and it condenses back down, and we're able to separate that out into this receiving flask. And so what we're relying on here are boiling points. So with paper chromatography, we're relying on polarity of molecules. With distillation, we're relying on different boiling points. These are both physical characteristics. If we need to separate a compound, now we're not separating a mixture, we're separating a pure substance. And if we want to separate a compound, we need a chemical reaction. As an example, we can separate water into its constituent elements by running an electrical current through the water. And when that happens, the water molecule is actually broken apart and we get hydrogen and oxygen. So in this one, we have a chemical reaction. The reactant becomes the products. Water becomes hydrogen and oxygen. Okay, that's it. And that wraps up Unit 1. As always, if you have any questions, please let me know.